back to our machine design series. Today we are going to have a quick video on thread production. Now, the standard methods of producing threads on threaded fasteners is broken down into either cutting or rolling. And I'm going to put a link in the description below to some videos showing you the cutting and the rolling process so you can see what they actually look like and the differences between the two manufacturing processes. And then once you've taken a look at that, then come back here and we can discuss how it changes the strength properties of the threads. So I'm going to try to draw a cross-section of a small portion of a threaded fastener for both cut and rolled threads, and then let's talk about it. Okay, so first of all, let's just define what we mean by cut and rolled threads. For cut threads, material is removed from a bolt blank, meaning really just a simple cylinder of material with either a cutting die or a lathe. And then for rolled threads, the bolt blank, that cylinder of material, is rolled between two reciprocating serrated dies. Okay, so if I were to first, let's imagine that we have our bolt blank here so that this section of material is still rectangular. And if that were true, then let's take a look at what might happen to some planes of material. So here's the original planes of material in our bolt blank. Now, when I use a cutting die or a lathe to cut this material away, I am simply going to remove this material that is outside of the shape of the threads that I want for my bolt. And so the plain sections of material from the original bolt blank will remain plain. Now let's look at what happens when we roll the material. So I have these planes of material from the original . Okay, but now when I roll that blank between the two reciprocating serrated dies, what I'm doing is I am compressing this material, particularly, down here where we're compressing down to the root of the thread. And so now my material is going to sort of follow the shape of the thread. So you can see that down here at the root of the thread, we're going to get a lot of compressive residual stress, and that is really good for the strength of the bolt, particularly in fatigue applications. So if you are using a bolt for an application where you know you're going to have lots of vibrations or high potential for fatigue failure, then rolled threads are probably the way to go. There's some advantages of cut threads too. Let's write out the advantages of each and then compare the two. Okay, so let's look at the cut threads advantages. First off, we have lower tooling costs, right? Because we only need a cutting die or a lathe if you're making your own non-standard size fastener. you probably will be able to find a lathe in your machine shop that can help you do that. Then we have that it's better for large diameter or non-externally threaded fasteners. And lastly, it's most common for internal threads. So for nuts, you will almost always have cut threads on those parts. For rolled threads, we get a more accurate and uniform thread dimension that has to do, at least in part, with the fact that when we're cutting our threads, we are also heating up the material, and then when it cools, it's going to contract, right? And that leaves us with a cut thread that is a slightly different size from how we originally cut it. And so you're going to have larger tolerances on your cut threads than on your rolled threads. We'll also get a smoother thread surface. So when we cut threads, we can be left with nicks and burrs on the surface, whereas rolling threads tends to give us a nice smooth surface finish. And lastly here we have a greater thread strength, and that's for the reasons that we've already discussed, that we get these nice compressive residual stresses, particularly at the root of the thread, which is where we have the highest stress concentration. Now, determining whether you need rolled or cut fastener threads for your application depends on your specific application's requirements and considerations. So you'll have to weigh things like strength, durability, precision, and cost effectiveness. Your rolled threads will generally be stronger, more resistant to fatigue, thanks to these compressive residual stresses that are generated in the rolling process. Cut threads, on the other hand, are going to be more flexible in terms of the range of thread sizes and shapes that can be produced. They're just easier to manufacture. They can be repaired or modified easily if necessary. And so cut threads will be commonly used in applications where high strength is not as critical. For general manufacturing purposes, construction, and general purposes within the automotive industry, these cut threads are very standard, whereas rolled threads are more commonly used in critical applications that require high strength and reliability. So I hope this video was helpful. This was just a quick one going over the difference between cut and rolled threads. In the next one, we will talk about thread engagement, and then we will get to the juicy stuff. We'll get to talk about the static and fatigue failure of bolts. So stay tuned for that. Thank you for watching. Hope to see you in the next one.